In this short video, I'm going to show how to import spreadsheet data into the LV test. The data we'll use as an example is reset behavior at voltage drop, which is part of the ISO 16750 standard. To start with, we need a spreadsheet containing the data that we wish to play. The first two columns of the spreadsheet must contain the voltage and time values. Voltage is in volts and time is in seconds. In this case, I've used formulas to supply the maximum voltage, the transition times, the length of pulse, and the hold time between pulses. As you can see, I've also provided a graph to show the waveform that we're generating. So if I change the time for the pulse, you can clearly see the waveform that will be generated for the LVT. In part 4.6.2 of the standard, the times given are 20 seconds at the beginning, pulse times of 5 seconds with 10 seconds held between each pulse. These are the values we'll enter in the spreadsheet now. So we have 20 seconds at the beginning, a transition of 1 millisecond, which isn't part of the standard but is the speed at which we're going to allow the edges to move from one voltage to another, and then a pulse time of 5 seconds and a hold time of 10 seconds. You can see now that the waveform we generate is very similar to that shown in the specification. We now need to export the data to CSV. To do that, select the first two columns of your spreadsheet, the voltage and time columns, and the first row that contains the title. Choose another worksheet on the same spreadsheet. In this case, I've already created mine, and use Paste Special to paste the values onto the second sheet. We now need to change the description, or the title, which is the first row of the spreadsheet data, to say something that will be unique, as this will be used in the LV test unit to display this waveform. I've chosen to show the pulse time, as this is what will change for different exported versions. We now need to save this spreadsheet as a CSV, and so drop down the spreadsheet type, and I'm going to use the file name in the same way as I have the title. It will ask you about multiple sheets, so you OK the first question, and it says that the CSV data is not compatible with the workbook. Accept this, but remember to save your spreadsheet later if you want to retain these tabs with all the data. It may be worth opening the CSV file in a text editor and just checking that there is no superfluous data. I'm going to scroll to the end of this file and just delete the last comma, because this can cause problems importing data sometimes. Now we can import the data into the LV test software. Choose on the main menu Captured Waveforms and press the Configure and Run Test button. We need to go to the Captured Import tab to import the data. Choose the CSV file that we've produced, and you will see a preview of the data before it is loaded. If you wish at this point, you can change the description if you forgot to do so in the CSV. Also notice the globally unique identifier that is given to this waveform. This identifier will make sure that similar waveforms on other units will not have the same name. To load the data onto the PC, press the Save Selection button, and now go to the Captured Resample tab. Now we need to resample this data in a format that the LVT unit can use. You will notice that the left-hand list box of the Captured Resample screen now contains the title that we gave our spreadsheet. To resample this, we must use repeat counts because we have used very large times in our data. The test runs for around 320 seconds, and in milliseconds this would exceed the number of samples the unit can contain. Using repeat counts allows invariant data or ramping data to be used by choosing steps or ramps. We'll choose steps with a repeat count of 16 bits. I've chosen to leave the 12-bit value the default value, as this matches the current hardware. Click on the Resample button, and this data will now be added to the list on the right-hand side. The next step is to transfer the data to the hardware. Before we do this, just make sure that your resampling finished successfully by saying 1 success and 0 failures, and click on the Captured Transfer tab. Click on the Connect and Sync button. This will now communicate with the hardware and report which waveforms are already in its flash memory. Choose the waveform we have just imported and resampled, and choose an empty slot on the right hand side, which is the position you want to load the waveform. To load it to the unit, click on the Store button and wait for the data to transfer. This waveform is not very large and so transfers fairly quickly. Click on the right hand tab, and this will draw a preview of the data in the unit. We are now ready to play the waveform. Check that the preview looks correct and that you've had successes and no failures, and if you're happy, choose the Waveform Main tab. You'll notice that before I play, the voltage is set to 12 volts. To change this, click on Use Settings and change the voltage to the voltage you require between tests. I'll set this to 10 to match the test voltage. If you want fast transitions of the output when switching, ensure the Fast Output checkbox is selected. If you want the test to run for one set of pulses, this is 1 cycle, enter this value, and also check that the waveform number matches the waveform number that you stored the waveform to in Flash. When we press the play button, the waveform will then be played. Notice the green light showing you that the waveform is now playing, and after 20 seconds we should see the first pulse dropping to 9.5 volts. After 5 seconds, this voltage now will recover to 10 volts. The process will now repeat after another 10 seconds to 9 volts. At the end of the 320 second test time, the signal will be set to 10 volts, which is the voltage after test. This is the end of this demonstration. Thank you for listening.